Thank you for update. Thank you for reminder. Okay. So in static routing, manually we need to add remote network manually. So in dynamic means something automatically. You no need to add. Routing protocol will exchange the routing table. Okay. So we'll discuss here characteristic of dynamic routing. The purpose of routing protocol include the following function. Discover the neighbor, finding the best path. In dynamic routing, automatically routing protocol, nothing but router will discover the neighbor, who is the neighbor. Okay, and it will finding the best path. It will search the best path. So here how it will search the best path on the basis of algorithm. Okay, so when you will enable routing protocol, so algorithm will get enable. Algorithm will search the best path. Algorithm nothing but a step-by-step process, trial and error method. Okay, in static routing we was mentioning, okay, next hop IP address means we are telling to our router, if anybody is trying to communicate from our LAN to remote network, send the traffic to this specific next hop IP address. But here not. Automatically routing protocol will decide the neighbor. It will discover the neighbor, who is our neighbor. Maintain up-to-date routing information. Okay. Maintain up-to-date routing table. For example, if remote network is down in your network, we have 10 branches, 20 branches. Okay. If remote, okay, you configured static routing, you will not get any update. In static routing we don't have any update, so you will get remote route will be available in your routing table, but communication not possible. Automatic update is not there. But in dynamic routing, automatic update is there. Maintain the up-to-date routing information, choosing the best path in the available path. If multiple ways are available to reach the specific destination, okay, so it will select shortest path. Okay, how it will select the shortest path? On the basis of what? Less number of routers or else high speed link. So it's depend upon protocol. We'll discuss type of dynamic routing. If you are enabling RIP will select the best path on the basis of less number of router. But if you are enabling OSPF will decide the best path on the basis of high speed link. Okay, whenever the base path is going down, okay, finding the new path and forwarding the data through that best path. Okay, if best path is fail, automatically router will calculate, nothing but routing protocol will calculate the second best path. Okay, like here this is the advanced automatic update. Okay, if one link is fail, another link will be up automatically. Okay, if one router got the update, okay, so it will send to another routers. Okay, automatic update is there. Changes in network topology are updated dynamically. Okay, if any change, if any remote network is fail, okay, your routing table will get updated automatically. Only the directly connected network information is required for the configuration. Okay, for this is the advantage. Less administrative work. In static routing, manually we need to add all the remote networks. Okay, but here in dynamic routing protocol for configuration, dynamic routing protocol configuration, we required only directly connected network information. Okay, selecting the base path to the destination network, automatically base path will get selected. Finding the second base path if base path is no longer available. If one base path is failed, automatically it will find the second base path. More scalable. Okay, dynamic routing is more scalable. For example, as of now we have 20 branches. Okay, 20 routers are there. Okay, in future organization is increasing. Okay, organization is growing. So in that case, you no need to change the routing protocol. You need to add the networks. You need to add the branches. Scalability is there. Okay, so we are using for big network purpose, large network, medium network. In that case, we are using dynamic routing. Like Geo is using dynamic routing. Okay, BSNL, ISP side, on ISP side we are using dynamic routing. Big organization. Okay, big network. So here types of dynamic routing. Okay, if you want, you can take it. Take the snapshot, or else if you want, you can write down. Is it completed? Okay. Yes, other members. Okay, right. Okay. Next, take it. You have the study material. Sir will send link to you also. You will get same information there also. Same PPTs there also available. Completed. Okay. Okay, right. Next here, types of dynamic routing protocols. Okay. So here basically two types of dynamic routing protocol, IGP and EGP. IGP stands for Interior Gateway Protocol. Interior Gateway Protocol. Next one is Exterior Gateway Protocol. So interior nothing but within the autonomous system. Okay, what is the autonomous system? AS. Autonomous system nothing but group of routers. Okay, it is represented by some numbers. It's provided by INA, Internet Assigned Number Authority. So within the autonomous system number, for example, to communicate like within the autonomous system. For example, BSNL router to BSNL router, Geo to Geo routers, okay, ISP to ISP router, same ISP router communication purpose. One branch, for example, BSNL branch in India, like here, BSNL branch in like Telangana, another branch in another state, one branch in Hyderabad, another branch in Delhi, Bangalore, Chennai, like to communicate within the same autonomous system, same branch, okay, same organization, same company branches in different location. In that case we can use here IGPs, Interior Gateway Protocol. Okay, next is EGPs. EGP means to communicate between two or more different autonomous system. Okay, like to establish communication between BSNL to Geo. Okay, like this two different ISP, one ISP to another ISP communication purpose, we have the IGPs protocol. Okay, so EGPs, IGPs and EGPs. Under IGPs we have three types of protocol: distance vector protocol, link state protocol, and advanced distance vector protocol. What is distance vector, link state, advanced distance, we will discuss. Okay, these are types. Under EGP we have path vector protocol. Under distance vector protocol we have RIP, IGRP, routing information protocol, interior gateway routing protocol. Under link state protocol, OSPF, ISIS. Under advanced distance vector protocol we have the enhanced interior gateway routing protocol. Okay, this is hybrid of distance vector protocol and link state protocol. Okay, so first we'll discuss about RIP. Okay, RIP. IGRP, this is outdated. RIP also outdated for understanding purpose. We will discuss. Okay. In real time in production network, mostly we are using link state protocol. Okay. Under link state protocol, mostly we are using OSPF. Okay. So first we'll discuss about RIP. Next, to establish communication between one ISP to another ISP. Okay. To enable communication between two or more different ISP, we are using here BGP, Border Gateway Protocol. Okay. This is especially for internet. Okay, so we'll start first RIP. Okay, so before starting RIP, we'll discuss about classless and class full routing protocol. Classless and class full routing protocol. If you like here, take here a snapshot for this one. Types of dynamic routing protocol. Is it completed? Okay. Okay. Right. Class full versus classless routing protocol. Okay. So class full means RIP version 1, IGRP. These two protocols are class full routing protocol. Class full means what? These routing protocol will not support subnetting. Means it will support only full network. For example, this is my one router, one branch in Chennai, another branch in Hyderabad, one more branch in Bangalore. Okay. So like this is our like router to router connectivity, multiple branches. To enable communication between them, to establish communication between these different branches. Okay, so compulsory we need to use here like full networks. Okay, yes, default subnet mask, correct. Okay, here 201 dot network subnet mask is /24 here also is /24, and public network also should be class full network, default network. Is it possible nowadays? Nowadays, we don't have already IP address. We are getting subnetted IP address. We are getting subnetted IP address. Okay, a slash like here 26 /27. We are getting subnetted. We are not getting full IP address due to avoid the wastage of IP address. We are going through the subnetting. We are doing subnetting. We are dividing one big network into a small networks. So subnet mask will get changed. So right now to establish communication between this Chennai to Hyderabad, Chennai to Bangalore remote networks. Okay, so we are not using full networks within the line, within the office. This is our wish. We can use class less or class full. Okay, but in public network always we are using subnetted network. So to communicate with remote network we require here routing. We need to enable here what? Routing. We are enabling, for example, RIP version 1 IGR. It will not work. It does not support the subnetting. Okay, this is class full routing protocol. RIP version 1 IGRP. That's why this is outdated. Okay, Cisco devices, Cisco is recommending no need to use. This is outdated. Nowadays in production network, anywhere we are not using. This is one drawback. Like this, so many drawbacks are there. We will discuss. Okay, do not send the subnet mask in the update. Only it will send network IDs. This is the problem in class full routing protocol. So nowadays we are not using class full routing protocol. We are using which one? Class less routing protocol. Means RIP version 2, EIGRP, OSPF, BGP. Okay, static routing, floating static routing, default routing. We are using class less routing protocols. Okay, support subnetting. It can support subnetting. Right now to communicate with remote network we are using subnetted network. Yes, it's possible right now. Communication possible because we are using classless routing protocol. RIP version 2, EIGRP, OSPF carries the subnet mask in the update. Okay, so nowadays we are using only classless routing protocols. RIP version 2, EIGRP, OSPF. Getting RIP is outdated. RIP version 1, version 2 we are not using. But we need to understand how it will work. Okay, then easily you can understand EIGRP, OSPF also. Got it? Got the difference between classless and class full routing protocol? Is it okay? Right. Yes, all of you. Okay, right. Okay. So first we'll discuss RIP, Routing Information Protocol. Okay. So what is the nature of RIP that we are going to discuss here? So this is our topology. Like this is my topology. So for example, you are the administrator, you are here. You are here. Okay. This is your branch. You are the administrator, you are taking care of Chennai LAN network. Okay. So right now tell me your router belongs to how many directly connected networks? How many routes are available in your routing table? 3. Okay. These are the directly connected routes. Okay. I'm writing here. Okay. For example, this is our Chennai router. 192.168.201.0 subnet mask /24. Next, this one 172.16.0.0. Is it correct? Next, 172.18.0.0. This is our directly connected networks. Okay. So in routing table, when you will check routing table, okay, for example, you are checking your routing table. How to check the routing table? Yes, network IDs. Show IP route. Correct. This is your routing table. You are giving this command, show IP route. So in routing table, what you will see? 3 directly connected network, 192.168.201.0/24. And this network belongs to fast Ethernet 0x0 interface. Okay. Next, 172.16.0.0/16. Okay, /16. This network belongs to serial 0x0. Next, 172.18.0.0/16. This is belongs to serial 0x1. What is the name of these routes? What is the name of these routes? Yes, same is directly connected networks. These are your directly connected networks. Okay, these are the directly connected networks. So right now in our routing table, which routes are not available? Okay, which routes are not available? I'm writing in red color. Okay, so here these routes are not available. 192.168.202.0 network. Okay, next is 192.168.203.0 network, and this is 172. Right, 17.0.0. This is your remote routes. Okay, so to communicate with these remote routes, okay, for example, you are trying to communicate from this PC1 to this PC2, like means 201.10 computer to 202.10 computer. Means in short, what we can say, LAN 1 to LAN 2 communication, Chennai to Hyderabad LAN communication. If you are planning to communicate, if you are establishing communication, so right now communication is not possible. PC1 to PC2, because in your routing table, you have your directly connected networks. Directly connected routes are available, but remote routes are not available in your routing table. Okay, so in that case, we required here routing. We need to configure routing. So right now, you can configure a static routing. You can configure a static routing, or else you can configure dynamic routing also. For example, you are configuring a static routing. So which one is the best path you will decide to reach from Chennai to Hyderabad LAN? How many ways are available to reach? You are in Chennai. To reach from Chennai to Hyderabad LAN 202.0 network. How many ways? How many ways? Directions. 2 directions are available. Serial 0x0 and serial 0x1. 2 ways are available. Getting? Which one is best path you will decide if you are configuring static routing? Which one you will decide the best path? Correct. Serial 0x0 is the best path, shortest path. But serial 0x1 also one another way, but it's long route via Bangalore. Getting? So this is the nature of static routing. Manually we need to decide the best path, shortest path. Getting? But dynamic routing protocol automatically will decide best path. You no need to worry. Okay, if big network is there, in a small network you can manage it, you can decide. But if big network is there, hundreds of routers are there, okay, thousands of networks are there, okay, logical network, in that case it is not possible, very difficult. So in that case, we need to use here dynamic routing. So in short, what we can say, to communicate with remote network, you are, okay, you are in Chennai land. To communicate with remote network, we required here routing. Getting remote route should available in our routing table, then communication possible. Understood? Okay, right now I'm checking here a Hyderabad router routing table. Show IP route. In Hyderabad router routing table, how many routes are available? 192 dot. How many routes are available? 192, 168. Mr. Ram, please check properly. How many directly connected routes? 192, 168, 202.0. Getting 172.16.0.0. 172.17.0.0. Okay, these are the directly connected routes. Okay, 3 directly connected. Similarly in Bangalore router, how many routes are available? Here also 3 routes. Okay, I'm writing here 3 routes. 192.168.203.0, 172. Okay, 17.0.0, 172.18.0.0. These are our directly connected routes. Okay, so right now in our Chennai router, we have our directly connected routes, but remote routes are not available. That's why we need to configure here routing. Okay, so we can configure static routing or else dynamic routing. Okay, so for example, you are enabling here dynamic routing. So then dynamic routing, how it will work? Configuration is very simple. Okay, working is very important here. Okay, nature we need to understand. Okay, what is the nature of dynamic routing? What is the nature of static routing? So dynamic routing is automatic update. Okay, here means give and take process is there. Okay, Chennai router will send routing table to whom? Hyderabad. Hyderabad will give the routing update to whom? Chennai router, like this. Okay, give and take process. Like here, RIP, what is the characteristic here? How it will work? It is a distance vector protocol. Okay, RIP, it is a distance vector protocol. Distance, nothing but here what? Routers between source to destination. Vector means direction. Okay, vector nothing but here directions. Okay, so see here, to reach, this is your router, this is your LAN network. Okay, you are here to reach from your LAN network to remote network. So for example, multiple ways are available. So for example, this is your LAN 201.0 network, and this is 10.0.0.0 network. To reach from router A, okay, like this is Chennai router. To reach 10 dot network, we have 3 ways: 1, A, B, and C. You are enabling here distance vector protocol. Okay, so how it will work? Which direction it will decide, A, B, or C? First, it will check what distance. Distance nothing but routers between source to destination. So like this is the source and this is the destination. To reach from source to destination, total how many routers? Via A link 3 routers. Via B link total 4 routers. Via C link, okay, 5 routers. Getting? So distance vector protocol, first it will check the distance, then it will decide the direction. So here this is the less distance. Distance not in kilometer, meters. Okay, distance nothing but here less number of router. Okay, less number of that router, that will be the best distance. That is nothing but best path. So right now tell me which one is the best path right now here. A is the best path. Getting? A is a best path. So this is the distance vector protocol. First it will decide the distance, then it will decide the direction. It is a open standard protocol. Means what? It is a standard protocol or else open standard protocol. Means this protocol we can enable in Cisco as well as in non-Cisco router. For example, in head office we have the Cisco device. In branch office we have non-Cisco device. Non-Cisco means Juniper, dealing different device, different router. In head office Cisco, in branch office non-Cisco, like this. In that case, if you are enabling communication between them, remote network communication, okay, you are enabling RIP. Yes, you can enable right now. Okay, you can enable RIP. It is an open standard protocol. It will work in Cisco as well as in non-Cisco devices. Okay, it is open standard protocol. Uses Bellman-Ford algorithm. Okay, algorithm nothing but here step by step process. Okay, to select the best path. Okay, it is a trial and error method to select the best path. How it will work, we'll discuss. It is a classless routing protocol. Okay, so RIP having two version, RIP version 1 and RIP version 2. Okay, RIP version 1, version 2. Okay, so here we are discussing about version 2. A small difference is there during the configuration. We need to mention version 2 command. If you are not mentioning version 2 command, it means you are configuring RIP version 1. Getting RIP version 1, it is class full. RIP version 1 class full. It will not support subnetting. But RIP version 2, it is class less. It will support what? Subnetting. Getting, it will send the subnet mask in the update. Okay, understood difference? This is one difference. Okay, class full, classless. Second difference is what? RIP version 1, it will do what? Broadcast. Means this is your router, it is connected on internet. It will send update to ISP router, ISP, like it will send to all the routers, it will do broadcast. But RIP version 1 will do what? Multicast. Okay, RIP, for example, this router is connected with internet and here limited in some routers RIP configured. Some other routers also there. So it will send update to only RIP routers. Only RIP router will get the updates. Okay, RIP version 2 will do what? Multicast. 1 to specific group communication. Only RIP router will get updates. Other router will not. OSPF router will not get updates. Getting? But RIP version 1 broadcast 1 to all. It will send traffic to all. Means it generate lots of unnecessary traffic. Here limited traffic. Which one is best among this RIP version 1 or version 2? Version 2 is best. Getting? Metric here, hop counts. Okay, hop count nothing but here what? Physical device router. Okay, so what is the metric? Metric nothing but here what? Unit of best path. Unit of best path. Like Indian currency, what is the unit? Rupees. US currency, what is the unit? Dollars. Getting? So here unit of base path is what? Metric is nothing but unit of best path. Okay, so here base path is calculated on the basis of hop counts. Hop count nothing but hand over the packet. Nothing but here physical devices from source to destination. Okay, so like this is our topology. Router 1, router 2, router 3. Okay, and multiple ways are available to reach this destination. 10.0.0.0 network. Okay, from this LAN, this is your LAN 201.0 network. Like this is one way. Here multiple devices, multiple routers, and this is another way. Okay, so this is your LAN to reach from this Chennai, to reach from Chennai to 10.0.0.0 network. Okay, so like serial 0 by 0, serial 0 by 1, serial 0 by 2. Okay, how many ways are available? 3 ways: serial 0 by 0, serial 0 by 1, serial 0 by 2. Okay, so right now here 3 ways are available to reach from your router to 10 dot network. Okay, which one is the best path? How it will get calculated? Less number of routers. Okay, serial 0 by 1. Okay, why? Because less number of hop count. So here this is the distance between two routers, two networks, two LAN, 201.10 to 10 dot network. Like this is one hop count. This is distance between these two routers. This is one hop count. We can say like this is one hop count. Okay, this is another hop count. This is one more hop count. So via serial 0 by 0, how many hop counts? Via serial 0 by 0, how many hop counts? 3 hop counts. 3 hops means 3 routers are coming between source to destination from your router. Okay, from your router, Chennai router to destination, 3 routers between source to destination. 1, 2, 3 routers, or else like this also we can calculate 3 hop counts. Via serial 0 by 1, 1, 1. Total 2 hop counts. Via serial 0 by 2, how many hop counts? 1, 2, 3, 4, right. 4 hop counts. 4 routers. Which one is the best path? Who will decide? Which one is the best path? Serial 0 by 1 is the best path. This is the best path. Okay, miss what? Miss entire communication from 201.0 network to 10.0 network, or else we can say like here LAN 1 to LAN 2, entire communication via this way only. Entire communication via this way only. Total communication, total traffic will flow via this way. This is the base path. Okay, so here hop counts. Metric is here what? Hop counts. Okay, less number of hop count, that will consider as a base path. That will be the base path. You are not doing anything. You are just enabling RIP version 2 in your routers. That's it. Automatically router will decide the base path. Getting? Because algorithm is running. Bellman-Ford algorithm is running. It will decide base path automatically. You no need to do anything. Only you need to advertise your directly connected network, nothing but you need to enable RIP. Understood? So maximum hop count is 15. Means what? From source to destination, like this is the source 201.0 network to destination router, like here this is the destination router to 10.0.0.0, like this is the remote LAN. Okay, so between, for example, source to destination, like total 15 routers, maximum hop count 15. For example, from source to destination, for example, let's say here hop counts, total 20 hop counts from source to destination, like this source to destination. Right now communication possible? No, communication is not possible. Okay, so here in RIP we have some limitation. Means what? Your data packet can cross maximum 15 hop counts. Means 16 router it can cross. For example, 20 hop counts between source to destination, like here 20 routers are there. Communication not possible. This is the drawback here. Okay, your packet can cross maximum 20, like 15 hop counts. More than 15 not possible. For example, source to destination 20 router, 25 routers, 17 routers to 18 routers, communication not possible. So this is the limitation here. Means maximum your packet, your data can cross 15 routers. 20, 25, 30 routers not possible. This is the drawback. That's why this is a big drawback of distance vector protocol. That's why nowadays in production network we are not using here. Getting? This is the problem here. Okay, that's why we are the solution OSPF. Okay, in OSPF hop count unlimited. Okay, source to destination means your packet can cross unlimited routers. Getting? There is no limitation. That's why distance vector protocol, entire distance vector protocol is outdated, no more in use. Okay, clear this one? Update are sent through the multicast address 224.0.0.9. Means this is the medium between all the routers. Update are sent through the multicast IP address, okay, 224.0.0.9. This is the medium between all the routers. Means your router is sending update. Update nothing but what? Okay, here new terminology, update. Update means what? Your entire routing table. Okay, you are directly connected networks, like this 3 directly connected, whatever, 3 directly, 4 directly connected. This is your update. Okay, your router will send this update. How it will send update? With the help of this multicast. We are not configuring anywhere this IP address. This is reserved for RIP. Okay, 224.0.0.9. Okay, means with the help of this is a medium between all the routers. With the help of this medium, router 1 will send update to router 2. Okay, this is a medium between all the router. With the help of this IP address, router will exchange the updates. Update nothing but routing table, route information. Okay, you are directly connected. Okay, or else remote networks. Router will exchange the routes with the help of this IP address 224.0.0.9. Okay, RIP send the periodic update for every 30 seconds. Okay, RIP sends periodic update for every 30 seconds. Means this is a continuous process. Okay, this is a continuous process. For example, you configured RIP here. Right now, just you enable RIP in your routers. Okay, in router A, in Chennai router. So what this router will do? It will send update to this serial 0 by 0 interface, serial 0 by 2, 0 by 1, and 0 by 0 like this. Okay, first it will send update. Update nothing but routing table. So update will come here. Okay, again after 30 seconds, again update will send. Again after 30 seconds, like every 30 seconds. This is the periodic update. This is periodic update. Every 30 seconds, router will exchange the routing table every 30 seconds. Getting? Every 30 seconds. This is the nature of RIP. RIP support equal cost load balancing. Okay, RIP support equal cost load balancing. Load balancing means what? Like this, we have multiple links between source to destination. Right now, tell me here. Which one is the best path to reach from source network to destination network? Like this is destination 10.0.0.0 network, and this is our LAN network. Serial 0 by 0 is the best path because less number of hop count. Okay, this is the best path. For example, you are trying to copy, like this is the server. Okay, this is the server. You are trying to copy some data. Let's say data size is 500 MB. This is the size of data. Okay, so entire data you will download from this server via which link? Link 1, link 2, link 3. Via link 1, serial 0 by 0, because this is the best path. But RIP support what? RIP support equal cost load balancing. Load balancing means nothing but what? Load balancing. Nothing but sharing the load to the multiple link. Okay, sharing the load to the multiple link. See, right now we have 3 links. Link 1, link 2, link 3 to reach same destination. But it is not equal. Okay, via serial 0 by 0, 2 hop counts. Via serial 0 by 1, 3 hop counts. Via serial 0 by 2, 4 hop counts. Getting? It is unequal, difference. Getting? So right now load balancing is possible or not? Not possible. Getting? Because links are, all 3 links are available, but hop counts are different. RIP support equal cost load balancing. For example, here one more router is there. Getting? Right now via serial 0 by 0. Okay, how many hop counts? 3 hop counts. Via serial 0 by 1, 3 hop counts. Right now tell me how many base paths? Total we have how many base paths? 2 base paths are available. Serial 0 by 0 and serial 0 by 1. 2 base paths, because hop counts are same. Okay, in link 1, 2, like 3 hop count. In link 2 also 3 hop counts, 3 hop counts, 3 hop counts. Okay, RIP support equal cost load balancing means if you are trying to copy some data from like this, your like Gmail server. Okay, so right now the data traffic will come here. Okay, right now this router will send 1 packet here, 1 packet here, 1 packet here, 1 packet here. Means it will do what? Load balancing. Means you will download your data. Okay, 500 MB data, like 250 MB data via link 1, 250 MB data via link 2, like this. 1 by 1 load sharing. Understood this one? RIP support equal cost load balancing. up to here only. By default, it will support 4 path. Maximum it can support 16 path. If source to destination 4 links are available and all the link having same hop counts, like here in my case 2 is there, 2 more like same. Okay, from source to destination 4 links are there. Okay, link 1 hop count like here 3, link 2 3, link 4 4, like this 3 3 3 3 hop counts. Right now load balancing is possible. Yes or no? Yes, load balancing is possible. For example, one more link is there, but here hop count is 4. Right now via 5th link, load balancing is not possible. For example, here also hop count is 3. Load balancing is possible. But by default not possible, Mr. Ram. Load balancing is possible, but by default not possible. Because by default it will support maximum 4 link. Okay, by default 4 link, 4 path. Okay, up to 16, but up to 16, right? Getting? By default we need to increase, we need to use command maximum hop count 5. Getting? Maximum path 5. Like this we need to configure that command. Understood? Next, complete routing table send as a update. What is the nature of RIP? Complete routing table send as a update. Like this is our router 1, router 2, like this here. So this router will send update, complete routing table. So whatever routes are available here, it will send as a update to other routers. It will send update as a router. Each update can contain maximum 25 routes. In one update, like this, our router is sending update to other routers. Okay, in our routing table, for example here 20 routes are available, means 20 networks are available. So our router will send this one as a update to other router. So what is the capacity here? Maximum it will send in one update. In one update it can send 25 routes. Let's say in our routing table, let's say here there is 100 routes are available. In our routing table we have total 100 routes. Right now how it will send update? Yes, it will send 4 update. In first update 25 routes. In first update. In next update 25 routes. In third update 25 routes. In fourth update 25 routes. One by one, 1 2 3 4, like this, automatically. Okay, randomly it will send. Okay, administrative distance here what? 120. Administrative distance here what? 120. For example, to communicate with remote network, if you are configuring 2 routing protocol like this 10.0.0.0 network, this is your remote branch. Okay, so here 201.0 network. To communicate with remote routing, remote network, you are configuring here, let's say here RIP. So administrative distance is 120. So router will give the priority to only RIP. There is no competitor. Okay, you configured here RIP. For example, at the same time you are configuring OSPF also. Okay, for backup purpose, like one more you are configuring. So here administrative distance for OSPF 110. Okay, in upcoming sessions we will explain about OSPF. So here administrative distance 110. So router will give the priority to whom? RIP and RIP or OSPF. You configure 2 protocols. Router will give the priority to whom? Lesser the administrative distance, more the priority. Okay, means lesser the administrative distance. Administrative distance nothing but what? It is the rank of the protocol. Okay, administrative distance it is the rank of the protocol. Okay, reliability of protocol. Less is the best. So you configured here OSPF and RIP. So your entire communication from this your LAN 201.0 network to 10. network, how communication will take place? Via OSPF. Okay, OSPF will be in operation. Getting entire communication via OSPF. Okay, uses UDP port number 520. What is the nature of RIP? It's work on UDP. It is a UDP protocol. Okay, 2 routers. This is our 2 routers, 201.0 network, and this is 10.0.0.0 network. Okay, for example, we enable here RIP, here also RIP. Okay, we enable here RIP. So what RIP will do? It will send update every 30 seconds. So our router will send update here. Then this routing table will get update, and this router will send update here. this router will get update. Means right now, as of now, 201.0 network is available. This is directly connected. After completion of RIP, remote route also will get update here like this. So this is the RIP route right now. Getting? So right now, remote route, this is our motto. Remote route should available in our routing table, then communication possible. Getting? But this is RIP protocol. RIP, it is in nature UDP. It's work under UDP. It is UDP protocol. Means what? It will keep sending update. Okay, it will like every 30 seconds. Every 30 seconds it will send updates. It's work under UDP. Means your data, your update is reached to destination or not. UDP, like RIP, is not responsible. Okay, your destination is alive or dead. Your router will keep sending update every 30 seconds. Getting? Because in UDP we don't have any three-way handshake process. Getting? We don't have any acknowledgement. For example, this router is dead, but router 1, Chennai router, will keep sending updates. Getting? It will keep sending update. This router is failed, but it will send update every 30 seconds. Periodic update every 30 seconds. Getting? It is in RIP, it is in UDP in nature. Okay, it will keep sending update every 30 seconds. No need of any acknowledgement. Okay. So RIP also called as routing by rumor. Okay, routing by rumor. Rumor means what? Rumor means what? Yes, or else in simple words, what we can say? False information, wrong information. Okay, also known as routing by rumors. For example, like this is our router, router 1, router 2, router 3. This is our LAN network 1, network 201.0 network, and this is 172.16.0.0 network, 202.0 network, here 172.17.0.0 network, and here 203.0 network. So in router 1, like router 2, router 3. So in router 1, how many routes are available? Directly connected. 2 routes, 172.16.0.0, 192.168.201. Okay. When you will configure, this is our directly connected network, and 202, 203 and 7, these are the remote network. So when you will configure RIP in all the routers, router will exchange the routing table. So remote route will come in your routing table. Remote route will come in your routing table. So right now here 202.0 network, 203.0 network, and 172.17.0.0 network. So remote route will available in your routing table. So remote route, like here, if you are configuring RIP, it is represented by our RIP routes, and this is directly connected routes. Getting? This is directly connected. So right now remote routes are available in your routing table. So everything is fine. Communication right now possible with remote networks. Okay. For example, here like 203.0 fast Ethernet 0x0 network is fail. Okay, fast Ethernet 0x0, this network is fail. This route is fail. Okay, 203.0 route is fail. Network is fail, like physically some generic network is fail. Okay, so but still 203.0 network is available in our routing table. 20 still it's available. Okay, but already we discussed RIP, it is a dynamic routing protocol. You will have here automatic update. If network is fail, you will get the update. But see, still this route will available. So for example, here one more router is connected. So what this router will do? It will make this one as a update, and it will send to whom? Other router. Getting? This is a dynamic routing. Here also RIP configure. But this route is failed, so it will update to this one. Getting generic, this network is failed, some problem is there, but logical route, this router 1 will update to other router, it will spread wrong information. There is already we discussed the RIP does dynamic routing protocol, automatic update is there, okay, but after 240 second, this route will get delete from our routing table. Okay, from this 240 up to 240 second, like router 1 will spread wrong information, false information. Understood? That's why RIP also known as routing by rumor. It will spread the wrong information. Getting? But up to limited time of breath. Okay, it will up to 240 second. It will spread wrong information. For example, just now 203.0 network is down. Some problem is there. But this 203.0 network route information is available in our routing table. Okay, so what our router will do? Router 1, it will spread. It will send to other routers. Okay, I have the information. Okay, 203 dot route is available. Okay, I have it. I will send to you. I will send to you like this. It will send to others. Generically, this is down. So it will spread wrong information up to 240 seconds. Getting 240 seconds. After 240 seconds, this route will get removed. This is called flush timer. This is called flush timer. Understood? Why it is called routing by rumors? Yes, all of you. Yes, correct. Okay, because correct. Okay, there is no acknowledgement. Okay, like here, this is another example. Like here, this is our topology. Okay, this is our topology. For example, I'm enabling RIP. I'm enabling RIP in this router. I'm enabling RIP in this router. Okay, after then one by one we'll enable RIP here also, here also. Like in all the router to communicate with remote network, I'm configuring RIP here. Okay, so what my router will do, what CCNA router will do. Okay, when you will enable RIP, how to enable, I will show the configuration later on. First, I'm showing here how to, like how it will work, mechanism, internal mechanism. So for example, I just enable RIP. Okay, so what RIP will do, it will send update. It will send update to whom? Hyderabad. Same, it will send update to whom? Its neighbor Bangalore also. Okay, it will send update. So like this update. This is update from Chennai. This update from Chennai to Hyderabad, like this. This is the update. Okay, so update nothing but routing table, entire routing table. So like this update will come. This update from Hyderabad. Sorry, this update will come from like this entire routing table, as it is routing table. This is from Chennai to Hyderabad router. What is the information here? 192.168.201.0 network with subnet mask, 172.16.0.0 network, 172.17.18.0.0 network. Like this update from, this is the update from Chennai. To whom? Hyderabad router. Hyderabad router will open the update. It will check update. What is the information in update? Networks, route information. Understood this one? This is the internal mechanism. Update is coming from Chennai to Hyderabad. So Hyderabad router will check the update. It will check the update. What is the information? 192.168.201.0 network. So it will check its own routing table. 201.0, is it available in the routing table? 201.0, whatever new information is came, is it in this entry is already available or not? If not, okay, it's not available, so it will add in the routing table. Okay, so I'm using another color here, like this is the new network. Okay, it will add new information, 192.168.201.0, getting /24. How it's coming? Via 172.16.0.1, like this IP address information. Got it? What is the name? RIP route. This is coming due to RIP protocol. After then it will check. Next one, 16.00, is it available already in the routing table? 16, yes, so it will discard it, it will not take it. 18 is available in the routing table. 18, no, it will take it, it will write down, it will add the entry in the routing table. 18.0.0.0, okay, slash 16. How it's coming? Via which IP address? 172.16.0.1. Same Chennai router is sending this one. What is the name of this route? RIP route. Got it? Understood this one? This is the internal mechanism. Okay, we need to enable. Simple configuration is there to enable it. Same, one more update will come from Bangalore. Okay, from Bangalore to Hyderabad. Hyderabad router will get update. What is the information inside the update? These routes, 1, 2, 3 routes. Okay, I'm writing here. This update is coming from Bangalore. 192.168.201. 203.0, 172.17.0.0, 172.18.0.0. Getting? Router will open the update, it will check. Okay, 203.0, is it available in our routing table, Hyderabad router routing table? No, it will add. It will add. What is the network? 192.168.203.0/24. How it's coming? Via Bangalore. So Bangalore router IP address 172.17.0.2. Next, 17 is available. Yes, it's available. 17 is already available. Discard. This is our directly. 18 is available. Yes. 18. 18 is available. Yes, 18 already available, but via Chennai. Via Chennai it's available. But right now it's coming via Bangalore, so it will add. Already route is available, okay. But to reach this destination, 2 ways are available. Okay, via 16.0.2 we can reach, see here. This is the network. 18, this is the network. How many ways are available to reach from Hyderabad router? 2 ways. Via Chennai we can reach here, right? 2 ways. So here it will add via 172.17.0.2. 2 ways are available. Understood? This is the internal mechanism. Same. So here this is the name of route, RIP route. Same update will come from Hyderabad and like same update will come from Hyderabad and Bangalore to Chennai. Okay, so Chennai router will route check, open the routing table, it will check. For example, this route will come. Okay, so routing table will check like here 2.2, is it available in our Chennai router routing table? 202.0 network, is it available? No, it will add in the routing table 192.168.202.0. 16 is available. Yes, it's already available. 18 is available. No, like 18 already available. 17, no, it will add 17, 172.17.0.0. Getting? After then one more update will come from Bangalore, 203.0, is it available? 203.0, no, it will add in the routing table. Our router will add 192.168.203.0. okay, next 17 is available. Yes, already available. Okay, next 18 is available. Yes, it's already available. And then it will give here what name. This is the RIP route, this is also RIP route, this is the RIP route. It will add subnet mask information also, /24/16/16, as well as okay, as well as here hop count information like here. Okay, so to reach 202.0 network, how many hop counts? To reach from our router, we are here, to reach from our router to this LAN, how many hop counts? Only one. Okay, one hop count. So that information will be available here. So first you will get here administrative distance 120. This is the administrative distance. One hop count is 1. Okay, to reach 17 network, how many hop counts? 2 hop counts. Administrative distance 120. So 2 ways are available here. 2 ways. Next, 203. Administrative distance hop count is 1. Administrative distance 120, hop count is 1, like this. Got it? So right now in our routing table, 3 directly connected routes are available, 3 remote routes are available. So right now Chennai to Hyderabad, communication possible? Chennai to Bangalore? Yes, communication possible. Okay, so here this is the syntax. Okay, how to enable RIP. This is the syntax. First write down the syntax, then I will discuss about syntax. I will explain about syntax. First write down the syntax. In all 3 routers we need to configure RIP. Is it completed? Dynamic routing protocol we need to enable under router mode. Today we will see new mode. You know already about setup mode, user mode, privilege mode, configuration mode, interface mode, line mode. Okay, so all the dynamic routing protocol RIP, OSPF, EIGRP, okay, BGP we need to enable under router mode. So when you will type in configuration mode router RIP, so you will be in router mode. Okay, then we will give command version 2 command and IP routing command to activate the router, to enable the router. By default router is disable. You can't see the routing table. Router will not do different network communication, packet switching, packet forwarding, right, without activating the router. Okay, so by default router is disable, means by default IP routing command is not given. We need to give the command. Okay, so first of all we need to give IP routing command, so your router will get activate. This is the key of your router. Okay, so we'll discuss about this command, how to enable this one. Is it completed, all of you? Right. Okay. Okay, I'll show the example here. So this is our same topology. So first of all, like this is my PC 201.10 computer. Default gateway should be what? 201.1. Okay, like this is another computer. Okay, like this is another computer. Here IP address should be what? What is the IP address of Hyderabad LAN computers? PC1 IP address, Hyderabad 1 PC1 IP address. Right, 202 dot something, for example 10. Default gateway 202.1. Okay, here 203.10, 203.1, like this. Okay, IP address should be in same network, like this. So how to access the router? How we are accessing the router? Is there need of console connectivity as of now? Console connection is required. Why, Mr. Ram? Already we have initial configuration in our router. Right now we can access using IP address. Is there need of console connectivity as of now? No need. Getting? As of now, no need, because initial configuration is there. We will open here command prompt, CMD, in our computer. We will open here command prompt. Okay. We'll check the routing table. We'll access the router by using telnet. Telnet space router IP address 192.168.201.1. Then you will be in which mode? User mode. It will ask password, user mode. After then enable. Then you will be in privilege mode. Getting? We'll check here routing table. Okay. First we'll enable routing here. Then we'll check the routing table. Show IP route. Show IP route. Okay. Yes. So right now Chennai router belongs to how many directly connected networks? 1, 2, 3 directly connected networks. Okay. So you'll see 3 directly connected network in your routing table. Okay. So I'm writing here 3 directly connected networks. Okay. 201.0 network, 172.16.0.0 network. Next 172.18.0.0 network. Okay. Right now we will enable RIP. Right now remote routes are not available in our routing table. Okay. Right now we'll enable RIP in our Chennai router. Very simple commands are there. Okay. So we'll give command here what? Router RIP. Right now I'm enabling RIP. Okay. Then tell me, we will be in which mode? Configuration, not routing. Yes, IP routing. First of all, we need to give that command. For example, we gave that command. Then we will be in which mode? Okay. Then we will be in which mode? Configuration mode. Not only configuration mode. Configuration plus router mode. Configuration plus router mode. See. Configuration plus router mode. We are in 2 mode. Hyphen symbol is there. Okay. I'm telling like plus. Okay. Configuration plus router mode. But we are in configuration and router mode. 2 modes. Here we will give command version 2. Okay. Version 2. It means what? You are configuring RIP version 2. It will do the multicast. Okay. Then you will be in which mode? Again configuration mode and router mode. In short, I am routing RTR, router mode. Then we will give command here network space network ID. Okay. Network space network ID. So right now what we need to type? Network space network ID. Our directly connected networks. Okay. So in routing table, how many routes are available? In our routing table, how many routes are available? 3 routes. One by one we need to type. We required only our directly connected network information. Remote route is not required. Okay, in dynamic routing, like here we need to type 192.168.201.0 like this. Next one, network space network ID. Correct. One by one, right? Yes, right, Mr. Ram. 172.16.0.0. Okay, like this. One by one we need to advertise. This is called advertisement. 172.18.0.0. Complete. Then exit. Exit means what? After exit, then we will be in which mode? Right now we are in configuration plus router mode. No need of subnet mask. Automatically it will take it. No need of subnet mask. See, after exit, we will be in which mode? After exit, configuration mode. Getting? Configuration mode. So this is our Chennai router. We will be in configuration mode. One more exit. Then we will be in which mode? Exit means one step back. Okay. Not user mode, Mr. Mustafa. Direct not. Privilege mode. One step back. Okay. One step back. Privilege mode. Getting? Privilege mode. Like this is the configuration. Please write down the configuration. This is our Chennai router configuration. This is our Chennai router, first router configuration. Chennai router configuration. Okay. This is in, write down the syntax. Like this is the configuration. No need this one 1600. This network is not required. Like this we need to configure. This is Chennai router configuration. Instead of like exit, you can use and also. See, this is Chennai router configuration. Okay, you can use this one. Is it completed? Right. Yes, all of you, please write down it. Then I will show the lab practical. Is it completed? Yes, all of you. Hello, can you hear me? Right. Okay. Try to configure Hyderabad router. In Hyderabad router also same thing. Like this is your Hyderabad router. How many directly connected routes here? Again 3. 1 LAN and 2 WAN. Okay. 1, 2, 3. Okay. 172.16 like this. Okay. Same configuration in Hyderabad also. Okay. And same configuration in Bangalore. Okay. Okay. So this is the syntax. This is Hyderabad router. This is network 1700. This is comes under loopback. Sir will explain about loopbacks in OSPF. No need serial interface. This is routing. No need interface. This is Hyderabad router. Okay. Directly connected network we need to advertise, and this is the Bangalore. Okay. No need this one 18, 16, 17. No need this one. So this will come in the OSPF. So I will explain about loopback interface. Then you will understand. These are physical interfaces, physical network, logical. These are logical networks. 201. Take the snapshot for this one. Okay. Next, verification. Write down the verification command. So first we'll check the routing table. In routing table, you will see your directly connected networks, and you will see here remote network also. Okay, C is means directly connected, and remote network is represented by R. R means RIP routes. R for RIP. RIP routes will be there in your routing table. Okay. Main our motto is what? Remote route should available in our routing table. Okay. So you can use command show IP route to check the routing table. Next one is what? Show IP protocols. Which protocol is running in our router? Like this is our Chennai router. Which protocol is running? Right now we configured RIP. So we can check by using command show IP protocols. Okay. You'll get the information, update, timers, everything. Okay. Show IP protocols. Okay. So I will show the labs. So this is my here topology is available. Initial configuration and when configuration is there. So this is my topology. This is my topology here in packet tracer. So here this is my like Chennai LAN network. This is Hyderabad LAN network, and this is a Bangalore LAN network. Okay. Chennai LAN network is like 192.168.201.0 network /24. Hyderabad LAN network, according to this, whatever we discuss in our topology, same /24. Here 192.168.204.0. Sorry, 203.0 /24 like this. Next here 172.16.0.0 network. Here 172.18.0.0 network. 172.18.0.0 like this. 17.0.0 like this. Okay. So this is my router. I'm clicking on first router, router 1, like that, nothing but that is Chennai router enable. I'm accessing the direct through console. Okay. We can access by using telnet also. Initial configuration is there. So this is my router. Initial configuration is there 201.1. Okay. And WAN configuration 16.0.1. Okay. 18.0.2 like this. IP address is configuration. Okay. Configured means interface configured. We'll check in short. Show IP interface brief, all the interface information. See here. Interface fast Ethernet 0x0, status up and protocol is up. This is my LAN interface. Serial 0x0. This is my WAN interface. Serial 0x1 WAN interface. Okay. On serial 0x0, which router is connected? Hyderabad. On serial 0x1, Bangalore router is connected. Like this, status up and protocol up. Physical layer and data link layer is up. Everything is fine. Got it? Is it clear? Right. Okay. Let's check Chennai router routing table. Show IP route. See, right now in my routing table, how many routes are available? C means directly connected routes. This is my directly connected routes. Remote routes are not available. Getting? What are the remote routes? We are in Chennai. We are here in Chennai LAN. We are in Chennai LAN. We are here. Okay. We are here. We are in Chennai LAN. So we have 3 directly connected route. 1, 2, 3. 3 directly. But 202 network is not available. Okay. 203 like these networks are not available in our routing table. Okay. So we will add it. We can add it manually or else with the help of dynamic routing also we can add. So this is my Chennai LAN computer 192 like here IP address 201.10. 201.10. Okay. Can I communicate from my Chennai LAN to Hyderabad LAN 192.168.202.10? Possible communication? No. Getting? Yes, all of you. Right now communication is not possible. Why? Why communication is not possible? Because in my routing table, okay, only we have directly connected source network information is available, but destination network is not available. What is the destination? 202.10 computer. 202.0 network should available in our routing table. Then communication possible. Getting? So what we will do? We'll try to ping. See, right now communication is not possible. See, reply from 192.168.201.10. Sorry, 1. Miss, which device IP address? Gateway, correct. Nothing but router. Router is telling what? Reply from router. Router is telling what? Yes, we need to configure. That route is not available. Okay, destination host is unreachable. That route is, I don't know about 202.0 network. Okay, that route is not available. So we'll configure right now RIP. Telnet. We'll access router by using telnet 192.168.201.1. Password is Zoom. Enable password is Cisco. Okay, like this. Show IP route. This is my Chennai router. So configuring here RIP router. So first of all, we'll give command IP routing command. IP routing command. See, this command is not working in this router. So in some iOS version, by default this command is given. This is my 12.2 operating system iOS version. Okay, so by default in this iOS version this command is given. You no need to give command. Okay, direct you have to start the configuration, RIP configuration, enable the RIP. So I'm enabling right now our router RIP. See, right now I'm in which mode? Configuration plus router mode. Hyphen miss, I'm telling plus. Okay, after then version 2. Okay, for example, you are not giving this command, it means you are configuring version 1. So in all the branches version 1 should be there. After the network space, network ID 192.168.201.0. I advertise my LAN network. Next 172.16.0.0. Next 172.18.0.0. Finish configuration. Very simple. Getting? You no need to bring remote root. Yes. Okay. It's already available. Just you need to advertise. See, we advertise the route. Right now, RIP will work. Okay. In static routing, we need to add remote route manually in our routing table. But here, you no need to do like this. You need to just advertise this network. So what RIP will do, it will send update in the update, it will send this information. Whatever route you are advertising, it will send update to others. Getting? This is the nature of RIP. Okay, Mr. Ram. Yes, it's already available in our routing table. Correct. You are correct, Mr. Ram. It's already available. We need to advertise. Then what RIP will do, it will take this one route and it will send to other routers. It will send to others. It will keep sending update every 30 seconds. It will make one update. Okay. It will combine them. It will send to all the routers. It is called advertisement. RIP advertisement. Okay. Exit. Exit. Show running configuration. So this is our RIP we enable here. Getting here router RIP. Okay, whatever we advertised like this. Okay, show IP route. See in my routing table, are you getting any change here? No. Why? Because just we configured our side. In other router also we need to configure. Then we will get updates. Okay, so you done your job. Yes, correct. You done your job. You are the administrator for Chennai. Same Hyderabad administrator also should configure RIP. Okay, same Hyderabad person. Okay, should configure RIP. So here desktop telnet Hyderabad router 192.168.202.1. Okay, password is Zoom. Enable password. I configured here enable secret Zoom. Okay, like this. Show configuration terminal. We will enable routing first. IP routing. See, this is supporting. Here version is show version. Here version is what? 12.4. Okay, 12.3 on what? IP routing command will work. But below that one, by default, that command is given. Okay, show IP route. So here also 3 directly connected network getting here 16, 17 and 202. Here we'll enable RIP. Router RIP. Okay, version 2. After then network space network ID. In short, I'm writing 172.16. Already it's available in my routing table. Only directly connected network information is required. 172.17.0.0. Next 192.168.202.0 like this. Exit. Okay, show running configuration. Check the like whatever configuration in RAM. Hitting RIP. Yes, router RIP is there. Same process. After then we'll check the routing table. Same process we'll do in Bangalore router also. Enable password is Zoom. Sorry, enable password. I configured Cisco. So we'll give that command IP routing. See, this is not working here. Here also operating system is 12.2. So by default that command is given. We can check direct routing table, show IP route. 3 directly connected networks. Configuration terminal, router, RIP, version 2, network space, network ID. 172.17. This is our directly connected network. You can copy paste also. Say I'll copy it. Copy and then paste like this. This is our direct. Just need to advertise our directly connected network. Only directly connected network information is required. Like this. C's means you are directly connected networks. Okay, like this. Finish configuration. Let's check. Show running configuration. This is RIP we configured. Okay, so first router, Chennai router. Okay, we'll access Chennai router. In Chennai router, we'll see the changes. Which type of changes are there? Show IP route connected. See, connected means our directly connected network. Already it was available. Okay, right now I'm checking here what show IP route RIP. See, RIP routes are available. Getting directly connected routes also available. This is our own. It was already there. Right now after RIP we are getting here these routes. Getting, see, 202.0 network is available, 203.0 network is available, and 17 network also available. Getting, in all, like in by using single command, all the routes show IP routes. See, total routes show IP route, directly connected and remote also. See here, 202.3, 202.0 network is available. What is the administrative distance? 120. Hop count 1. Got it? To reach this network, 203. Bangalore, 1 hop count. To reach 17.0 network, how many ways? To reach 17.0, how many ways? 2 ways. Via 16.0 to Hyderabad router, via 18.0.1 also we can reach. 2 ways are available. For this network, load balancing is possible. Got it? Right now, Chennai to Hyderabad, Chennai to Bangalore, communication possible? Yes or no? Yes, possible. Let's will try to ping 192.168.202.10. Possible? Yes. Reachability is there. Correct. Trace route, we'll check the path. Trace RT 192.168.202.10. So how communication is taking place? 16.0.2. First traffic is going to my router. After then 16.0.2 Chennai, Hyderabad, and then destination. So this will be the best path. So from here, this is the best path. Getting? For example, this link is fail. Which link? From Chennai to Hyderabad link is fail. Okay. So I'm removing this connectivity. I'm removing this connection. See, I remove this connectivity. Right now, tell me, Chennai to Hyderabad communication possible? Yes, all of you. Yes, communication possible. Okay, communication possible. Let's check our routing table. Show IP route. See, that route is not available. That will come in next update. Bangalore will send next update after 30 seconds. Getting? See the difference. Right now we got the update. Are you getting difference? 202 is available right now. Okay. How many hop counts? To reach 202.0, 2 hop counts. Getting? 120 is administrative distance, 2 is a hop counts. 2 hop counts are there. 2 hop counts. Getting? Reachability is possible. Getting? Reachability is possible. Let's will check the communication. We'll try to ping once again. 202 dot, yes. See, TTL value is reduced. Means our packet is crossing 128 minus 3 routers. 125 we are getting TTL value. Let's trace route. We'll check the path, how we are reaching there. Getting this one? First, my computer is sending request to my local router 201.1. After then, Bangalore router 18. After then, Hyderabad 17.0.1, and then destination. Got it? So automatically it will select the base path if base path is fail, base path is down. Okay. So again we will connect here. Just will connect here connectivity. Like this is my connection. Serial 002, serial 001, like this. Let's check the routing table. You'll see the difference here. Show IP route. See, still there is no change. Update will come. See, update came. Getting? To reach 202.0 network, Hyderabad LAN. Getting here? 1 is hop count. So right now entire communication via. Yes. Okay. We'll try to ping. Yes. Again as it is. Okay. TTL value 126. Our router is crossing only 2 routers. Got it? Link is up. Again, Old one is the best path. Serial 0 by 0 is the best path. Okay. So this is our RIP configuration. Okay. RIP, all about RIP. Okay. What is the problem here? See, what is the problem here? See, right now remote routes are available in our routing table. Everything is fine. Okay. See, right now here, this is my Chennai router. Okay. For example, same process in Hyderabad, Bangalore also. Conclusion. This is the conclusion for RIP right now. So right now 202, 203 and 17 remote routes are available. This is a remote route. 202, 203, like these are the remote routes. Remote routes are available in our routing table. Getting? Remote routes are available. Is there need? See, right now this 202, 203 fully converged means it is available in my routing table. Right now my router knows about this route. Getting? Is there need another update? For example, already 202, 203 route is available in my routing table. Okay, it's available already in my routing table. Again, update is required here. Is there need? No need. For example, simple example to understand this one. Okay, because it's sending update every 30 seconds. This is the nature of RIP. Already that route is available in my routing table. This information is not required. If any change is there, then that information is required. But there is no change. What RIP will do, every 30 seconds it will keep sending update. This is a periodic update. Every 30 seconds. Every 30 second update will come. Every 30 second update will come. It is similar like, for example, Balu sir is coming like afternoon 2 o'clock online on webinar on WebEx, and he is introducing every day. Hi, my name is Balu. I am CCNA faculty in Zoom technology, like this. Every day he is introducing himself. Is it good? Is there need every day? No, already you know about Balu sir. Getting? You know about Balu sir, his faculty is teaching every day CCNA to you. Okay. So everyday introduction is not required. No need. Getting? No need introduction. Already first day everything is completed. You know about Mr. Balu. Getting? No need this one information. Okay. But what RIP is doing, every 30 seconds it's sending update. Every 30 seconds. Every 30 seconds. This is the nature of RIP. Getting? If update is not coming here up to 240 seconds, this is the hold down timer, flush timer, 240 seconds. What Chennai router will do, you are not sending update, I will delete your information. Okay, you are like Hyderabad router is not sending update, I will delete after 240 seconds. Every 30 second update is required. This is the nature of RIP. This is called periodic update. This is called periodic update. This is the periodic update. Every 30 seconds required. If other router is not sending, so our router will delete that route from. So this is here what unnecessary traffic. Okay. If for example Hyderabad router is sending some new information, means updated, new some different thing, that is okay. Changes is okay, but same information is not required. So due to this problem, in overall in distance vector protocol, this is the problem here. Every 30 seconds keep sending updates. No need everything. Okay. We required which update? Not periodic update. We required here dynamic update. If change is there, change is required, but that is not possible. That's why here unnecessary traffic. Okay. It will use more bandwidth. It will use more bandwidth. This is the problem in RIP. That's why overall RIP, or else we can say distance vector protocol, RIP, IGRP, this is outdated. We are not using now. Getting? Unnecessary. Instead of that one, we are using link state protocol. Instead of this one, we are using link state protocol. Okay. Here which type of update? Like every 30 seconds, same information multiple times, not like that. If there change is there, then Hyderabad router will send update to Chennai, new information if change is there, otherwise no. Getting? So it will use less bandwidth. Getting? So this is the advantage in OSPF, link state protocol. Okay. So today we will stop here session. This is RIP, do the labs for RIP. Okay. And next tomorrow sir will continue. Okay. Thank you for session. If you have doubt, you can ask me.